Good morning, good afternoon, and good evening, everyone, depending on from where you've joined. Welcome to today's webinar by Data Platform Geeks. My name is Rohit, and I will be your host for today. Today's session is on Azure Databricks. It will be taken by Viresh Kumar, who's from Microsoft, and our moderator today will be Satya Ramesh. So eDominer Systems, a lot of you already know about eDominer Systems and its popular brands. We have SQLMaestros, under which we offer a lot of advanced training on data and analytics, including SQL Server, data science, and a lot of other technologies. We have the learning kits, the video courses, and the unique hands-on labs, which I will talk about later. We have Peopleware India, where we offer a lot of corporate training, and of course, our popular ERP product, that is Expand SME ERP. Last but not the least, we have Data Platform Geeks, our community of which you are part of. Under that, we have our annual summit. We have the Data Platform Summit. It was formerly known as SQL Server Geeks Annual Summit, and we had 2 years of that conference in 2015 and 2016. It was renamed in 2017, being called the Data Platform Summit, and then we had it in 2017, 2018. We recently launched Data Platform Summit 2019. You can, on your screen, you can see the logo and the title. So it will be a 3 days of conference on August 22nd, 23rd, and 24th. And we will have 3 days of pre-cons this time on 19th, 28th, and 21st. We will have about 18 pre-cons spread across 3 days. And 14 of those pre-cons have already been announced and up on our website. This is an image from the last summit, that is DPS 2018. You can see more than 1,000 people at the summit here, coming from 300 countries and 300 companies and 16 countries. On the stage, you can see Rohan Kumar, who is the corporate vice president of the Azure Data Group from Microsoft Redmond, and his entire Redmond team. As I mentioned, DPS 2019 will be a 3-day conference on 22nd, 23rd, and 24th, and the pre-cons on 19th, 20th, and 21st. We'll be focusing on 7 tracks, and there will be more than 100 sessions at the summit, delivered by 50 plus world-renowned speakers. One of the main reasons DPS is so popular is because there is 100% learning and 0% marketing. And of course, the stalwarts that come along, whom you can interact with. If you want to learn more, you can visit dps10.com, or if you have any queries, you can write to us at contact@dps10.com. So they will be putting down all these links for you that you can use. So go ahead and register yourself for DPS. It is only Feb, and the conference is in August. But one important point I would like to tell you is that the price of the summit increases every month, the first of every month. So keeping that in mind, you can book your seat right away. The price for the summit will increase tomorrow. Today is 28th of Feb. So this is the lowest price of the summit you can get. So go ahead and block your seats right away. And if you would like to invite your company, or if you have a corporate nomination, you can always reach out to us by clicking on would you like the DPS team to invite your company. All that is there on the homepage. So visit dps10.com for all of those details. So why should you really care about the summit? First of all, it's about the professional education, the deep technical content by the world's best, and if you wish to reskill and upskill. And of course, the networking opportunities. You get to meet some of the world's best people and network with them and make connections for life. Data Platform Summit will happen at Radisson Blu, which is a 5-star property in Bangalore. That is one of the world's best infrastructure, in fact. And DPS involves the community. So what does that mean? Every session that you see at the summit for the last 4 years, or the summits that are going to come, are all decided by you. So we put down all the sessions up for voting, and you choose what you want to learn at the summit. And of course, there's highly curated content and disciplined execution. So go on and evaluate Data Platform Summit. Our past 4 conferences content is up on our website, all the videos, the keynotes, etc. You can see all of that, and all of the people's testimonials as well. So visit dps10.com and you will find a lot of details up there, and you can judge for yourself. Moving on, this is the DPG core team. We have Amit Bansal, the founder and president. We have Manohar Puna, who is the vice president. Avanish Panchal, Vijay Mishra, Vijay Reddy, Sandeep Pani, Prince Rastogi, Surbhi Agarwal, Sakharam Shinde, and Devdatta Nath are all our regional mentors from all over India. These are the eDominate teams from Bangalore and Kolkata who help us do all these events. On the stage, you can see Amit Bansal, eDominate team, and the DPG core team. This was at DPS 2018 last year. Special thanks to Microsoft for supporting us in our community initiatives. Without them, all this wouldn't be possible. So why join DPG? Most of you are already aware and have already attended a lot of our events. So you know all of it is absolutely free. We also have in-person events that are coming up on March 2nd and March 9th. March 2nd event will happen in Bangalore and March 9th event will happen in Hyderabad. So if you are living in those cities, you can register yourselves right away. And these events are absolutely free. Apart from the events, we also have free videos, labs, magazines, and a lot of other learning resources that you can use. To go ahead and use all of them. And we have recently come up with a new meetup model, which allows you to host DPG events in your company. So just fill out the regional mentor form and our team will get in touch with you. You can find the regional mentor form on our website, that is DataPlatformGeeks.com. You can also visit our SQLServerGeeks.com website. If you have any questions beyond this webinar, if you would like to ask the speaker any questions or the community any questions, you can write in our Facebook groups, our LinkedIn groups, and on our Telegram groups, and it will reach them. All our webinars are recorded and will be uploaded after the webinars are done. So will this webinar be uploaded. So you can visit our YouTube channel, that is SQLServerGeeks.com, to see all our old webinars. And if you wish to see any new SQL videos by our team, you can visit SQLMaestros, youtube.com/SQLMaestros. These are the 2 YouTube channels that you shouldn't miss. And do not forget to subscribe. So without any further delay, let's get started with the webinar. Viresh, Kumar, over to you.
Hi, everybody. Can you guys hear me? Am I audible?
Yes, Viresh, you are audible.
Super. Let me quickly share my screen.
Yes.
Let me know, guys, whenever my screen is visible.
Yes, perfect. We can see your screen.
Fair enough. Let me just quickly run the slide through. So hi, guys. This particular session we're going to do on Azure Databricks. And I'm Viresh Kumar from Microsoft, working as a big data specialist on the Microsoft internal projects. And if I talk about Databricks, it's one of the key services for database and compute as of now on the Azure cloud. And in this particular session, we'll talk in detail about how it facilitates all that big data processing, how it seamlessly integrates with Azure, and what are the key and specific benefits that we get out of the integration of Databricks with Azure cloud. So first thing first, if I try to tell you the first question, what is Databricks? So in a very simple term, the answer gonna be, it's a managed enterprise Azure service provided by Databricks to perform big data processing using the Apache Spark as the compute engine. So I know there are a lot of jargons and a lot of keywords in this one-liner statement. So let's begin with the first thing first. When we say it's a managed service, yes, it's an end-to-end managed service provided in the form of a first-hand Azure service. When we say first-hand Azure service, it comes seamlessly available as part of the Azure offering. When you go on the portal and look for all services tab, this one you will find listed out there. It's a managed enterprise service managed by Databricks in terms of enterprise support, in terms of updation of versions, updation of libraries, and all that is handled from the enterprise support group. The next important thing comes up to be is to perform big data processing. So ideally, this Databricks or Azure Databricks is meant to provide the compute layer for your data. And under the hood, this compute is addressed or facilitated by the Apache Spark compute engine. It's the same open source Apache compute, on top of which Databricks has written a lot of uh, updates, a lot of optimizations, and an integration layer with the Azure cloud. So in a nutshell, it's a managed service, Azure cloud service, which facilitates the compute of the data. When you say data, we are obviously talking about big data. Gives you a lot of handle to integrate your machine learning services, to do the prep and training of your experimental data and stuff like that. So whatever you can cover under compute, whenever we talk about compute or processing of the data, Databricks is, or Azure Databricks is the thing to go whenever we're talking in the context of Azure cloud. If I go through the official definition, which says it's a fast, easy, and a collaborative Apache Spark based analytics platform optimized service, and specifically carved out as an integration service for Azure. Summarizes what I've just said. What's the benefit when we integrate the enterprise compute engine from Databricks with the Azure or Microsoft? Definitely, we get the best of both the worlds. Azure is a mature cloud, has got a service offerings in most of the regions now, and with a lot of active data centers across East Coast to East Coast, West Coast to West Coast. We get almost high nines of fault tolerance, availability, and distribution of your data across. When you integrate this with the distributed data engine in a form of Databricks, we get a lot of advantages. And at the same time, Databricks is built in collaboration with the founders of the Apache Spark, and as a first-hand Azure service, it's give you an integration as a one-click setup. We'll definitely show you on the portal how you kind of deal with Azure Databricks. But yes, on Azure Databricks, it's give you a one-click setup. Gives you an interactive workspace to file your queries in the form of SQL, Scala, Python. A lot of languages are supported, and it could be used by people who are also not from the pure programming background. People like data scientists, data engineers, business analysts, to perform any kind of ad hoc analytics and trying to get the sense out of the underlying data, maybe in the lake or your Azure Blob, or say in a SQL Server, or in a Cosmos or Document DB. So it comes up with the adapter for all those. It has provided the native integration with Azure services and the Azure service paradigm, where you have a lot of the services which can talk to it directly, be it the connection with your Power BI as the visualization layer. As I talked about, it can connect seamlessly with the help of connectors from the other Azure storages like SQL, Cosmos, Blob, etc. Absolutely, it avails the best of the security paradigms provided by the Azure security in the form of Active Directories, compliance, enterprise grade SLAs, and stuff like that. We talked about Azure as a first-end service for Databricks. And what does it mean is that we can have a seamless integration with the other gambit of services provided by Azure, be it your storage services, your Active Directories, your on-cloud SQL data warehouses, NoSQL databases, your different streaming channels like Kafka and stuff, billing services, your visualization layer in the form of Power BI and others. So in a nutshell, what we're simply trying to say that Azure Databricks is a seamless integration on Azure Cloud, and like any other service on Azure, it's also a first-end citizen as a service, and avail and collaborate with all the other available service as part of the service offering. Now, this comes the interesting and important part. Before we actually go into what are the top facades, look and feel, and how to operate on Azure Databricks, let's go a little deeper into what exactly is Apache Spark, and how does it all moving towards streaming and Spark become kind of a de facto for your stream-based architecture. How it all started, I can say you have the Teradatas and SQL servers of the world trying to process the huge amount of data. Then came your Hadoop MapReduce world. Did a great job in terms of processing a huge amount of data in a batch processes. a new approach to process the data in the form of map and reduce. And then came Spark, altogether a new approach to process the data, where we're talking about a lot of input-output intensive, slow batch processing of MapReduce. We're talking about 100x faster Spark, and definitely we need to understand how it does that. Apart from that, an interesting fact about Spark gonna be like it gives you a coherent and seamless integration with any kind of data mode, be it batch or stream. It has got a layer to which gives you out-of-the-box connectivity with the available streaming channels, be it Kafka or your enterprise messaging services, be it your ActiveMQs and others. Um, it gives you an absolute parallelism and fault tolerance without even 3x duplication of data, how it happens in HDFS. Definitely something very interesting to know about. It gives you a high-level APIs in variety of languages, be it Java, Scala, Python, R, and has got the 4 components right now supported out of the box. Spark Core, Spark Machine Learning Libraries, Spark Graphics, and Spark Standalone Cluster Manager. The whole concept in Spark, how data is processed, is based on the design principle where the entire data processing is happening in the memory of the nodes of the cluster. And that's how it differentiates from the Hadoop MapReduce, where you process and involve in a lot of input-output activities. You have a mapper which produces some kind of key value pairs, stores it onto the disk. Again, your reducer comes, read it back, those key value pairs from the disk. And this is how you involve a lot of input-output, which definitely have performance penalty in when you're dealing with a huge amount of data. And obviously, one clear line of thought, we're talking about big data. Big data means we're talking about terabytes and petabytes and above that. And Spark has really made a cut through in terms of how data is processed in the big data world. And as per the official benchmark, what we have found it's around 100 times faster than Hadoop MapReduce, and we'll see how that happens under the hood. There's a high-level cluster architecture for Spark. Primarily, the entire setup is divided into that you have a driver program, which kind of initiates the Spark context, which kind of observe the entire compute or the processing of data in coordination with the cluster manager. Spark supports Yarn and Mesos as the cluster manager, and the recent announcement is that Spark is going away with cluster managers altogether, and Kubernetes will come into the picture as the container manager, and Spark will run on K8s, K8s, that is Kubernetes. But for a moment, it supports 2 cluster managers out of the box, Yarn and Mesos, and then you have different worker nodes where the processing will be performed by different executors. Different executors in itself can run number of different tasks. That means you have a paradise which is MPP, massively parallel programming is happening here. So you have first level of parallelism is achieved when you delegate the execution or compute to different nodes in the cluster. Then internally, each node would be processed by number of different executors, and inside each executors you would have concurrent tasks running in depending on number of core you have supplemented to the executors. But the whole idea here is to have massively parallel processing of the data, and that's the whole, and the eventual processing of the in the form of task happens within the first memory of those worker nodes. I'll go into the internals. This is how internals of a Spark job looks like. As soon as you do a Spark submit of say a particular Spark job you've created, the first thing would be your Spark context would be initiated, and then comes your different transformations and actions. As soon as you perform any kind of transformation, the request will go to the cluster manager for the allocations of workers and executors in the cluster. And cluster manager, which is definitely doing the housekeeping for the entire Spark cluster, will allocate the resources based on the request, and different worker nodes, which may not be eventual nodes, but different containers, maybe on a single physical machine. But yeah, different containers in the form of what we call as worker nodes in the Spark world would be created, and nothing would happen until eventually you will call any kind of actions. So that's the beauty of it. The entire Spark works in the form of lazy evaluation. You keep on giving your different transformations, different logical transformations which you want to perform on your underlying data, but nothing would happen until you can't any kind of action. As soon as the action is called, a job would be created. This is the triggering point for the creation of the job. And as soon as the job is created, the DAG, which is a lineage for different transformations that you have already performed before calling the action, would be uh, executed in the form of task on different worker nodes through the DAG scheduler. So DAG scheduler is the one who takes into account the lineage or of the transformations, what we call as DAG in the Spark world, uh, and assign these tasks to the different worker nodes, which are the Excel containers for the execution of the lowest unit, which is task in the Spark world. So if you try to analyze this whole internals of Spark at a higher level, you'll find that couple of important points how we are achieving the low latency in terms of compute is the lazy evaluations. Transformations are kept in the form of lineage, and then Spark engine execute them in the most optimized way. There are Catalyst and Tungsten optimizers under the hood, which take that entire lineage and create an actual execution plan, which is the most optimum in terms of resource and performance. And the entire computation of this task is happening within the memory, which obviously cuts down the input outputs and the disk communications, which obviously are slower than talking to the RAM. And that's how at a high level you achieve the performance what we are getting with Spark. Let's move on. There's a similar thing which we talked about. You based on your transformations DAG. DAG scheduler submits, creates the job, post the action is called, and these jobs are collection of different tasks, and tasks are further divided into stages based on whether it's a narrow transformation or a wide transformation. Any kind of transformation involves shuffling of data across different nodes in the cluster, what we call as wide transformations. Your narrow transformations where you don't have to shuffle data across the nodes. So based on that, taking all these factors into account, Spark will produce an optimized execution plan, and that's how everything would be executed eventually in a lazy format. Now, this was Spark, and what are the different internals of Spark? An important factor how the big data design principles are governed. If we talk about, there are two prevalent architecture design principles available in the big data world. The first one is the Lambda. Definitely, it's the first one came into picture with the Hadoop and MapReduce world. And this particular architecture specifies that we're going to maintain two different layers for batch processing and for your speed processing. When we say speed, we are primarily talking about event-driven architecture, streaming data which is coming continuously uh, with an infinite length and stuff like that. Primarily, you can categorize this data, say, coming from your IoT devices, or say coming from your maybe in the form of continuously spreading logs from different operating machines in a big system, or any kind of source which sending the data in the continuous and in the form of infinite length data, which we can categorize as a stream of data. On the other hand, we have the separate layer for batch processing, where the data is slow moving, kind of your OLAP systems, where we built in our Hadoop Lake and stuff like that, and try to process the data in the batch form. But the whole problem which arises with the Lambda architecture is you have two separate line of processing or compute that you have to maintain. And because you didn't have any coherent technology to provide you under one roof support for handling the stream and the batch data, you're forced to kind of pick different technologies, and thus have to maintain different code bases different logical bases for these two different layers, and eventually there's a huge cost how you merge the data across the batch and the speed layer and present it for your downstreams or for visualizations or for setting up any kind of data marts. Now the advancement in the Lambda architecture comes in the form of your Kappa architecture, is the lower part of the diagram. And the simple specification with with Kappa architecture is here everything is stream. So when we coherently say upfront that everything is stream, we are saying that we are not maintaining an additional batch layer. We may be doing batch processing, but we have a coherent single solution how we'll do the stream processing and the batch processing in one solution, in one code base itself. So we'll see in this particular slide that how Spark has kind of become a de facto implementation for your Kappa architecture. Spark is the only inherent technology, prevalent technology across right now, which provides you the seamless and the coordinated APIs both for stream and the batch processing. Similar set of APIs work across for stream and batch. At the same time, an integration layer is provided with a number of different connectors to onboard data from a number of different streaming channels, be it your Kafka, be it your IBM MQ or ActiveMQ, RabbitMQ, or any kind of other streaming channels or data movement channels. So if we check in this particular slide, definitely Kappa architecture is a simplification of Lambda architecture, getting us away from maintaining two parallel stream of code bases for data processing, which absolutely is clumsy, and you have to do dual work in terms of maintenance of two code bases, and then big headache in terms of how you merge the data across two layers. So that all gets away with Kappa architecture specifications, and Spark has become a de facto implementation for the same. Provides the single platform engine to support both batch and streaming data. Uh, for example, if we talk about pre-Spark era, when we try to try to do the compute for both stream and batch, we'll have to choose different set of technologies. Obviously, for batch processing, we have Hadoop and MapReduce, but for streaming, we had to kind of club it across for other technologies, be it Storm, Flume, etc. Right? But now with Spark, everything is provided as a single platform. Correct. So that was Spark, that how Spark has brought a change in terms of how data was processed and how data is getting processed in on current systems. Azure Databricks is the managed enterprise solution on top of Apache Spark. And this is how a typical landscape of Databricks, Azure Databricks looks like. Definitely gives a coherent support for both batch and stream so that you can onboard data from a number of different channels, be it your IoT streaming, be it from across cloud, your on-prem or on-cloud data warehouses, be it your SQL servers, the data, etc., or be it your typical HDFS Hadoop storage layer. Alongside with it, be it your Azure blobs or ADLS, Azure Data Lake Services, all that can be used to brought data into the compute zone of Azure Databricks. The entire Azure Databricks as a component can be broken into three layers. First is the collaborative workspace. That's the first motto why enterprise managed service provides, in the form of that a lot of people coming from different backgrounds can collaborate using the Databricks services in the form of notebooks that are available, and with a variety of language support provided. Uh, it gives you a complete DevOps handle from the Databricks service, Azure Databricks service itself, providing you how to host your Spark jobs, how to schedule them, and eventually how to create notification alerts and generate logs, which can be fed into any log analytics system. Apart from that, this is the icing on the cake, that the Databricks optimize the runtime engine provided by the native Apache Spark, add couple of specific and spatial components on top of it, like your Databricks input-output cache. Helps in terms of reducing any kind of performance penalty due to input-output or disk spillage. For instance, if you have some huge amount of data which is not been able to say contained within the primary memory of an individual worker node, obviously there would be spills onto the disk, and that specific cases are pretty nicely handled in the most optimized way through the Databricks input output uh, cache. Uh, at the same time, from the deployment perspective, added the support for serverless. So you can create your jobs from the Databricks services and allocate the machines. And the machines could be allocated from the cloud itself behind the scene, depending on the spike in the processing traffic. At the same time, give you an external set of REST APIs to kind of play around it from the external tools. APIs are pretty intensive and pretty exhaustive in terms of doing everything and anything on the Azure Databricks services, which you can do, say, from the UI or command line. Eventually, from the this is, if we talk about from the ingress perspective, we had a lot of channels available. Similarly, from if I talk about the digress perspective, a lot of output or eventual systems can take input or can be fed from the data services, from the Databricks services itself, be it your different machine learning models, your visualization tools, your underlying data marts, or any kind of NoSQL or database systems could be plugged in with the connectors provided out of the box. Nonetheless, mention about the HDFS and Azure Data Lake integrations out of the box. This is how a typical workflow or an we can say an architecture at high level looks, how you integrate your big data warehouses with the Azure Databricks services. You can bring data from a lot of different input sources, uh, integrate it with the Azure Data Factory integration platform provided by Azure. Can read the data from a number of different storages, and Databricks component can be used to do any kind of data processing, be it prep and train to the different raw data coming to a system and eventually match it to the eventual schema of your underlying data warehouse or your database systems, or sending it eventually to any kind of analytic dashboards, how you want to massage and process the data. That all can done through this Azure Databricks service. Similarly, any kind of analytics or advanced analytics you want to run, Databricks can play an active role with the comprehensive libraries for MLib, Spark R, and others. Also, a graphics module provided by the Spark itself for visualization. And it can fed data to any kind of eventual publishing layer, be it in a form of Azure Cosmos or your analytical dashboards. Similarly, as we have already talked about, a coherent single interface for batch and stream. This is how you can onboard and analyze, perform analytics on top of your streaming data. Azure HD Insights provides a Kafka channel for streaming that can be hooked through the connectors with Azure Data Services, and data can be onboarded into the Bricks context and processed. Now let's come towards the functional aspect of the Bricks in Azure, how we can use it from the usability perspective, and how the integration of these two components makes the life very easy. It can be provisioned directly from the Azure portal. No need to kind of provision any special service or anything of that sort. And at the same time, we can club it, connect it with the other Azure services in the Gambit. So these are some of the screenshots that how we create the workspace. I'll take them as part of the demo. Now, very important factor, which is in the form of security, authorization, authentication, how we deal that we have a huge amount of data stored under the hood, maybe in the form of lake or your different NoSQL databases, or maybe your SQL servers and stuff like that. How, when I try to compute that data, how I can maintain the integrity of that data, how I can make sure that I have the right security checks, and how can I maintain the hygiene of the data, be it at rest or at motion. So there, the Azure component in the form of AAD, Azure Active Directory, comes handy. These are another services, security services provided by the Azure, and it is can be directly collaborated with Azure Databricks. Any user uh, accessing any other service in Azure through the AAD have the same effect. What it could be, say, using with Databricks. So you can define your access policies, access and controls, checks and balances through your Azure AAD, Azure Active Directory, what it say, also helps you to maintain the single sign-on for the user and provide the unified authentication across the cloud. That is absolutely true for Databricks, Azure Databricks as well. This diagram kind of depicts the same, that access control and authentication and security can be managed through the Azure Active Directory, which can act as a licensing between your eventual users and your any of the Azure services. Here in this particular context, we're talking about Azure Databricks as a service, and that licensing can be done by the Azure Active Directory. These are the nitty-gritties how access controls are pretty fine-grained and can be applied at the lowest grain. And we'll talk about in the context of Azure Databricks what are the different grains, artifacts, and components. So it kinds of this slide primarily trying to depict that different artifacts in Databricks like workspace, your clusters, jobs, REST APIs, and all that can be scrutinized or can be constrained from the security perspective at the lowest grade. This is what we are talking about in this slide as well. If you see this page, it's a fine-grained page to kind of apply security paradigm at the lowest level, be it your workspace cluster, be how REST API integration would happen, and how jobs can be accessed, restart, create, and stuff like that. All can be done through the Azure Active Directory. This is some more nitty-gritties in terms of what is the access control mechanism. Uh, if I try to take up this information at a very high level, two configurable type of permissions allowed for cluster in Azure, Spark cluster in Azure Databricks, where you have individual cluster permissions, which kind of gives the ability to user to kind of attach the notebooks with a cluster, run their ad hoc analytics commands in the form of SQL and Scala and stuff like that. And another one is the cluster creation permission, which obviously is the admin-like control, where you can define the definition of your cluster, the different parameters, tuning parameters, connectors, premium lining in terms of JDBC or DBC access for visualization and stuff like that, primarily towards the admin side of the cluster management on Azure Databricks. These are furthermore nitty-gritties that what kind of access that can be defined at the cluster level. The whole idea of these slides is to demonstrate that the security and the constraints can be applied at the lowest grain possible. Yeah, I mean, this is an interesting one. If you try to chart out what are the different core artifacts for Azure Databricks, the topmost to begin with is your workspace. Inside the workspace, you have a set of libraries. Specifically, some of them comes pre-bundle. At the same time, gives you a handle to uh, kind of upload external libraries, be it through Maven coordinates, etc., or in the form of direct jars. Then you can have clusters created for the execution of your Spark jobs. And then you can provide the definition of jobs in the form of job artifact provided by Azure. And the last but not the least are your notebooks, which kind of gives you an handle to do any kind of ad hoc analytics on the underlying data. You can directly hook yourself on top of the lake or any kind of storage under the hood using the connectors and run your uh, analytical queries, maybe in the form of SQL queries or Scala code or Python code that all can be executed right away using the notebooks. Now, the interesting factor: how do we use Databricks, and what kind of underlying file system provided by Databricks? So the file system provided what we call as DBFS. It's a Databricks distributed file system. This comes pre-bundled with the Azure Databricks services, and all the data which is available in your lake under the hood can be mounted in the DBFS, so that when your actual compute would happen, it won't have to do any kind of input outputs to kind of connect or hook directly with the lake. Everything would be onboarded on your DBFS. Depends on what is the topology of your cluster. Different nodes would be categorized as worker nodes, -1 obviously, which would be a name node for your cluster manager. But uh, that's how the data for compute would be brought in the distributed file systems available on different nodes in the cluster by the Databricks. And it gives you a lot of connectors that you can mount your underlying storage via through notebook or through your Scala enterprise code to kind of create this package. Your storage data can be cached locally on the worker nodes, as we talked about. Uh, your lot of language support is provided, that how you can interact uh, to compute data on Databricks. And obviously it comes pre-installed with your Spark libraries and cluster management handles. A notebook, a very important component if we talk about, and there are and if I talk about, if I can put an analogy, say with the Jupyter notebooks, pretty successful in terms of uh, how specifically your experimental machine learning experimental codes are written using that notebook. Obviously, because a lot of people in that set of um area doesn't come from a pure programming or engineering background, so it gives a easy handle. Same is the case with Azure Notebook. Easy handle in terms of writing your quick code and queries. Um, and obviously, with as integrated with the Azure Cloud, comes up with the uh, security and collaboration across other services in the Gambit out of the box. Definitely very well suited for prototyping, rapid development, discovery, and iterative development. Specifically for the ad hoc analytics kind of scenarios. Say for uh, some kind of data needs to be discovered across the lake or the big storages, can be quickly done using the notebooks. A great support in terms of multiple languages is provided by the notebooks. These are the different handles that you can write on top of your notebook cell and use the specific language to write your data processing. And databases are a collection of related tables, how DBFS Databricks file system understands it. And it gives you a visualization handle also how to create databases and tables uh, through the data from the underlying source, or you can insert the data. Comes with the underlying Hive metastore, which is not an external Hive store, but an implicit Hive store comes out of the box with Azure Databricks, so that everything and anything you are trying to save data in the form of tables with Databricks would be indexed with Hive, so that you can query, so that all your metadata information would be kept with Hive, so that you can write directly the Spark SQL or Hive query language to kind of read and write the data across. Mm, Apart from that, full support out of the box for whatever you can do in Apache Spark possible with Azure Databricks services, be it processing or handling of your data sets, data frames, and using the libraries, and doing any kind of partitioning, be at the table level, be at the code level, to create the push down predicates, to do the bucketing and all that is absolutely possible. I'll do a demo for that as well. The kind of tables at a very high level, they support two table types, your global tables and local tables. And the whole idea of global tables is that they're available across clusters, not the case with local tables. At the same time, your typical terminology of Hive, because under the hood there we do have Hive implicit metastore, your whole concept of external and internal tables is applied as well. Important, very important, Spark SQL, specifically with Spark 2, Spark SQL is already been enhanced to the another level. And now as a from the Azure Databricks perspective, also Spark SQL is a pretty distributed SQL Server query engine, which gives a good neck-to-neck competition in terms of how data is processed using the pure APIs with the Scala code or Python code, or kind of trying to write the SQL Spark SQL. We'll also look into the what are the official benchmarkings provided vis-a-vis Spark SQL versus Spark Scala and Python, etc. But the most important aspect that is catered in through the Spark SQL is that without losing the performance benefits, now people coming from the SQL background could be onboarded on the Azure Databricks services as a platform, and could write big stream processing or batch processing jobs to leverage the underlying engines with the SQL-like language. Most of it is Spark SQL is like SQL, and most of the um, functionalities are onboarded with Spark SQL as well. Important aspects why Spark is fast. We've already talked about it in-memory cluster computing, as we've already seen. The data is brought into the DBFS distributed memory from the underlying storage from where you're trying to read and write. And that is when it is supplemented from the hotbed to the actual compute, right? So that's the whole idea behind Spark, which makes it comparatively very faster. Scala integration, needless to say, Spark in itself is written in Scala. So it gives an inherent native support for Scala programming language. Most of the APIs provided in the Scala. At the same time, the clients for Spark are provided uh, in the form of other languages as well, like Python and R. But obviously, Scala gives the right mix when we talk about the integration with Spark. This is how we try to compare that. In the traditional MapReduce, you have a lot of input-output operations happening in between, where you have actual disk interactions, make the whole scheme of things slow. While we are talking about Spark as a compute engine, we're talking about to the primary memory itself. And that's how we are saving a lot of speed in terms of how the data is processed. Right. If you remember, in one of the previous slides, we talked about the special customizations and optimizations provided by the Databricks on top of native Apache Spark, and Databricks input-output cache happens to be one of them. It caches the remote data on the local nodes, as we have talked about. The data is stored in the DBFS to accelerate data reads. And this is something which is provided as part of the enterprise managed service from Databricks. At the same time, supporting a lot of different storages, but the whole idea is to cut on the input output. And that's where this DBIO, Databricks input output cache layer, comes into the picture. Can be leveraged. And this, if you see on the other hand, try to give some kind of stats. That's what kind of disk utilization has happened with Databricks input output cache into the picture, right? So we're trying to process, if you see this picture, we're trying to process kind of like 36 or 30 plus gig of data and on an individual disk. And we are only seeing the disk usage is 1%, which obviously is not the case with Hadoop MapReduce, I can tell you right away. Let's look into the what do you say as the official benchmark provided from the Azure Databricks side. It's 5x faster than the native Apache Spark on the AWS cloud. And it is 8x faster than Apache Presto. Difficult to believe, but that's true on AWS. Similarly, on the if you try to compare it with on-premise Impala provided by the Cloudera, it's at least 3x faster. So that's kind of official benchmarking provided against the other available compute engines like Apache Presto, Impala. Um, Definitely, MapReduce is not in the picture for this. These all are also in-memory compute engines, and it's an apple-to-apple comparison. And Azure Databricks happens to be the faster. It's kind of a high-level overview how Spark SQL actually executes behind the scene. So if you see this box of RDD and everything apart from that is the facade or the integration layer on top of your native Spark. So under the hood, your basic unit of data in the Spark world is RDD, right? All this is facade written on top of the native core libraries to onboard SQL language on Spark. And with the advent of Catalyst and Tungsten Optimizer, what would we see in the coming slide in the official benchmark that Spark 2 onwards, the Spark SQL is performing equivalent as it would be with Spark and Scala. So this is that benchmark I'm talking about. If you see Spark Scala, where we're trying to process data in the form of data frames and data sets, it's like neck to neck how it would have happened in the Spark SQL world. This kind of how you can do your analytics and the integration with the on-cloud SQL servers. As we've already talked about, any kind of storage you talk about, we do have the connectors out of the box, whether through the JDBC connectivity or on the TCP layer connectivity. Important Power BI visualization provided by Microsoft has gotten out-of-the-box connector for Azure Databricks services, where you can directly aggregate, or I can say massage data for visualization on the Spark itself. I mean, which obviously comes as a huge boost. If I'm trying to draw a visualization out of the big data kind of scenario, it makes more sense to perform aggregations using Spark as an engine rather than natively on the Power BI or any visualization of that sort. So we have the connector, JDBC connector, to connect with the Spark Azure Databricks services, and that's how data can be processed. And that data could be onboarded in the form of reports, dashboards, etc. A good time. Let's quickly look for a small demo that I've got. What exactly, how do we use the portal and the bricks? So if I go to the Azure portal, I do see a lot of questions, but I hope during my conversation I'm able to answer most of them. Like expansion of DAG is dynamic acyclic graph, which is the lineage of different transformations are performed before you actually call the action. Transaction consistency ACID is supported. We're talking about big data. All these technologies are in the ambit of CAP theorem. So ACID is not into the picture. Support unstructured data and structured data, obviously yes. How memory is managed, what is the memory required, say for 5 TB data. I mean, interesting point, depends on your cluster topology. But even with the standard core node of say cluster of say 10 node can easily crunch down 5 terabyte of data. If you have any more questions, do type it down. Fine. This is how your Azure looks like. And if we go to, let's try to create Azure Databricks workspace. We can see all these are the list of all the services are available. And if we'll go under if you see here, if we scroll a little down.
Viresh, I don't think we can see your screen move. Could you please?
You can't see my screen, is it?
We can just see your home slide. That is Azure Databricks, Viresh Kumar.
Okay. Do you see the Power BI demo page? Is it?
Now it's changed. Yes.
I think it took some time. Yeah. I hope everybody can see my screen now. Can you guys see my screen? Yeah.
Yes, Power BI demo. That's the slide you're on.
Yeah. Now I'm on the Azure portal.
No, not yet.
Not yet. Okay. Can you guys see me now? Can you see the Azure portal screen?
Still on the PPT. Just hold on. Just hold on.
Yeah. Just a moment. I think, do I have to specifically share? Let me. Can you see it now? I hope you would be able to see.
Yes, we did. Now we can see your portal.
Fair enough. So I'm on the portal. This is the Azure Databricks service, right? On the All Services tab. Probably if I go here, I can create an instance of a service, what we call as workspace, as we discussed in different artifacts of Azure Databricks. So here we can select whatever source group you can have, and you can go to add, and you can type it down the workspace name, select your subscription, and you can simply create. That's how an instance of workspace is created. This is how a workspace looks when you'll create it. And once this is created, you can launch this workspace. Once you'll launch this workspace, you'll get a number of different options in terms of how you can create a cluster for Spark, how you can create a job and stuff like that. So here is an option to create a cluster. If I click on that, I'll go to the cluster page. Here I can create a cluster for the execution of my Spark job. And I can give my cluster name. I can select the cluster mode, be it standard or high concurrency, depending on my usage. I can select the runtime environment. I'm going with Spark and Scala. I'm going with Python 3, right? I can select what kind of machines I do need. So this is the size of my cluster, which says minimum worker nodes 2, maximum worker nodes 8. So that means the maximum size of my cluster would be 8 nodes, depending on the spike. When the volumes of the data would be more, it will automatically kind of add more nodes, keeping the maximum to the 8 itself. And here I can define the type, whether I want to take a 14 gig 4 core, or I can want to take 28 gig 8 core, depending on what kind of cluster configuration I want to do. And this is how I can create a cluster. I can create a cluster, I can start that cluster, and then I can create a Spark job to run on that cluster. I can create a job. Similarly, people who are already working on a Spark, how they do, typically they write a Spark submit command. Similarly, that is one of the options. You can configure Spark submit. You can type on your parameters like your main class name, your path, your Uber Spark char, and other parameters in terms of executor, num executor, executor core, executor memory overheads, whatever you can do from there. You can create a job on the similar lines here. Another option is you can drop your Uber jar, write the main class or any kind of uh, you know, your arguments you want to pass to the jar. That's how you can create the job as well, right? Now let's see how the notebook looks. I can go to a workspace user. To my name, I can do create notebook, and you can create a notebook of your choice. And I opened up the notebook. For notebook, you can attach your cluster which you have created from here. You can attach a cluster, and then you can perform any of your SQL, Spark SQL or Scala code right in. Like if you want to create a table, Hive table, this is a command, and we have given this to make the cell aware that this is a SQL code. Similarly, similarly we can write this Scala code as well. Like if I'm trying to read a JSON file from the lake, I'm connecting with my Azure Data Lake and reading this data, and I can do the ad hoc analytics, execute this query right here, run the cell, and I can see the display the data. It'll run a Spark job behind the scene if you have just noticed, and I can see the data. Similarly, I can route CSVs and apply different APIs provided by the Spark, and can write almost anything and everything from SQL, Spark, Scala in this particular notebook to do any kind of doc analytics. Quickly, let's see how do we connect it with the Power BI. So I'll show you. Can you guys see my screen? I hope you folks can see my screen, right? My Power BI screen.
No, we are still on the Azure screen, I guess.
We're still okay. Okay, I hope you can see my Power BI screen. Let me know.
Yes.
Yeah. So I was trying to showcase that we can connect with the Azure Data Services right away from the Power BI. It's a visualization tool. If I go to the get data, so there is a connector provided out of the box from the Power BI, what we call as Spark, and I can connect it at the using the HTTP connections. These connections would be available in your cluster itself. So I can give my cluster URL in here, JDBC cluster connector provided, and can connect it. So it will connect, and it will list me down all the table and data available in my cluster. And then probably I can choose it, bring it into my Power BI and do any kind of reporting and visualization on top of that. So that's it in this particular session on Azure Databricks. I've taken 5 more minutes. Apologies for that. I hope you enjoyed the session. I've got one more question from Srinivas MA. How to estimate memory, CPU, and DBU? Very important question. Very important question. Probably I do not have time to get into the details of this, but yes, I can tell you at a very high level. It all depends that what is the volume of data you will prefer to process on a particular core, right? For example, if I'm say trying to process say 100 units of data, I'm not going into MBs or KBs, say I'm trying to process or compute say 100 units of data, and suppose I have a 10 node cluster with say 100 gig available on each node, right? And say each is a multi-core node, and say had 10 core each. So now I have 10 core 100 gig on a 10 node cluster, which means I have total 100 cores available, right? And I have 100 into 10 gigs of memory available. These are the two driving force how the compute how the compute would be done for the, say, 100 unit of data, right? Now I have to submit my Spark job in a way that I can be able to utilize the massively parallel processing paradigm of Spark, right? For that, if to my each executor, I say to each executor I'll give, say, the all of the 10 cores available on a particular node, right? I can do that. I'll say I'll give all of them to it, but if I do that, I'll not be able to run the processing. Why? Because I need at least one core to run the operating system and the background daemons, your data nodes, name nodes, or other processing daemons. So that means I can maximum allocate 9 cores, right? Similarly, I'll have to leave, say, 1 gig for operating system and daemons. So probably it leaves me with 9 core and 99 gig of memory on each machine. But this is again, I'm kind of trying to 9 core means, so this is like a maximum approach. So what we are losing out here is we have 9 cores available for each executor. That means each executor will run 9 tasks in parallel, which is not an optimized number from the Hadoop Lake perspective in Spark. If your underlying data storage is HDFS, right? The ideal number is 5. So to each executor, I should not allocate more than 5 cores. Similarly, if I have to process 100 units and I have 10 node clusters, say I'm processing 10 units each. That means to each executor, which is processing 5 tasks, right? To each executor, I should allocate at least 10 plus 7% of 10, which is the memory overhead. That means around 10.7. 7% of 10 is like 0.07. Yeah. So I should allocate somewhere around 10.07 gigs to each executor. This is a high level. When you do your Spark Submit, you can work out these calculations. I have a video also on that on YouTube. You can look for that, how to estimate the Spark Submit parameters, executor tuning. Any other question?
Okay,
I'm
we
done
did
from my
have a
side.
couple
Yeah.
of slides. So by the time I finish that, if people have questions, they can put it down in chat window, and at the
Sure.
end of it,
Yeah.
answer. Yeah.
Sure. Yeah. So thanks, guys. I'm done. I'm done from my side. Thank you very much.
Okay. Thanks a lot, Viresh. Sorry for the delay. Thanks a lot, Viresh, for that wonderful session. So if you have any questions beyond this webinar, like I mentioned earlier, you can join our Facebook, LinkedIn, and or Telegram groups where you can post your questions or answer questions from the community. And if you have any questions specific to this webinar, we will send it to Viresh and we will have them answered. So yes, this webinar will also be recorded and will be uploaded shortly. So SQLMaestros Learning Solutions, we have the masterclasses going on right now. We'll have 3 more sessions left, one on T-SQL, one on performance tuning by Amit Bansal, and the SQL admin class by Satya Ramesh. So if you have not enrolled yourself yet, so please go ahead and enroll. SQLMaestros.com is our official website. We have the SQL Server Performance Tuning video course that is coming up by Amit Bansal in March. It will be releasing in March, but you can register yourself right away. We have the unique hands-on labs that you can try out. Since you are DPG members, you can try out some of our free labs and then choose to subscribe. We have the learning kits, which is based on the SQL Server Performance Tuning course by Amit Bansal. And if you are in need of SQL Server health check, you can write to us. Our email ID is contact@SQLMaestros.com, and our official website where you will find all this information is SQLMaestros.com. Like I mentioned, we have announced 14 pre-cons already. Here you can see a lot of sessions on Power BI, Azure, data science, SQL Server, and SSIS, etc. And these are all the names you see here are all industry stalwarts, MCMs, MVPs, and Microsoft speakers from Redmond. So go ahead. Today is the last day for the lowest price of Summit. Go ahead and book your seat. The price will increase tomorrow for the pre-cons and for the Summit. For the people who are new to Data Platform Geeks events, we also have in-person events called Data Platform Days. These are full-day multi-track events that happen throughout India. Our upcoming Data Platform Days are happening in Bangalore and Hyderabad. So if you are in Bangalore or Hyderabad, do give a visit and attend these events. And these events are absolutely free, just like this webinar. And the tracks are on Azure, Data Science, BI, and Database Administration Development. So you know where to go. The website is dataplatformgeeks.com/events, where you will find all our upcoming events. So go ahead and register. See you at the events. So that's it from my side too. Follow us on Twitter. Our Twitter handle is SQL Server Geeks. And yes, this webinar was being recorded and will be uploaded shortly. You can visit our official website, dataplatformgeeks.com, and be part of our groups on Facebook and LinkedIn. So once again, thank you all for joining, and thank you, Viresh. Let's just see if you have any more questions. Okay, I don't see any more questions. All right then. So all of you, if you have any questions later, you can post it on the groups, and we will send it to Viresh. Thanks a lot. Thank you for your time. Thank you, Viresh.